Good afternoon, everybody. In this lecture, we'll be revising some concepts about soil and rock in terms of volumetric changes and volumetric units. So, if you remember from soil mechanics courses, that soil is constituted by volume into soil, water, and air, and in terms of weight into soil and water. From these from this column, we could get these nice relationships that you all know from soil mechanics. However, we are not using these relationships. We are using some of them. So mainly the specific gravity, which is the weight of solids over volume of solids over unit weight of water. And the weight of solids is simply as the weight of solids is the weight of soil over 1 plus W, which is the water content. Then gamma dry is simply the dry unit weight is simply gamma over 1 plus W. This relationship is something that we will actually be using in this course. And to review some concepts about volumetric changes of soil, imagine that you have 1 cubic yard of banked volume. So it's in its nature at state. When you cut it, when you fragment it, and hold it on trucks, this would be increasing in volume. So this is what we call the loose volume. So this loose volume is of course more than the banked volume. So it is more than it by an average of 25%. So it's an average of 1.25 cubic yards. So now the 1 cubic yards of banked units became 1.25 loose cubic yards. And after that, when it gets compacted, it will be 0.9 cubic yards as explained previously in a previous lecture. So the relationship between the compacted dry unit weight and the banked dry unit weight is denoted by what we call the shrinkage factor. Again, we say that on average, 1 bank cubic yard will produce us 0.9 cubic yards. But this factor could change from one type of soil to the other. So some soils will be 0.88, some will be 0.92, but the average is 0.9. So if we didn't give you the type of soil or we didn't give you the factor, then you could assume it as 0.9. On the other hand, what we call the swell factor denotes the relationship between the loose volume and the banked volume, the loose dry unit weight and the banked dry unit weight. So, as mentioned, on average, 1 bank cubic yards or 1 bank cubic meter will produce us 1.25 loose cubic yards or loose cubic meters. This is why you will find that it's always denoted by either BCY for bank cubic yards, LCY for loose cubic yards, or CCY for compacted cubic yards. For the SI units, it will be B meter cube, C meter cube, or L meter cubed. This nice figure I'm sure that you have taken before in soil mechanics. This is the Proctor test. So again, you have the standard Proctor test and the ASH2, by the ASH2, standardized by the ASH2, and the modified ASH2 Proctor test. The difference is mainly in the load and the height and the number of layers. But the concept here is what? You are reaching a certain optimum maximum dry density, maximum gamma dry. You're reaching this maximum gamma dry at a certain optimum moisture content. We call it the OMC. So this OMC will differ according to the type of soil. So here you are having 8 different types of soil. These 8 different types of soil, they have 8 different curves. These 8 different curves denote the relationship between the water content and the gamma dry. So in order to maximize the dry unit weight, you need to target the optimum moisture content at which this dry unit weight will be maximized. So in order to do this, we need to process the soil. So when adding water, you must consider the following. You must consider the amount of water required, the rate of water application, the method of application, and the effects of climate and weather. So, for example, if you are doing a job in an arid country like Saudi Arabia, it's totally different than if doing it in a rainy location like Britain. So, for sure, you must take this into account when calculating the amount of water. The method of application, we'll be discussing it. It's typically trucks. The amount of water required and the rate of water application, we'll be discussing it in details now. So when adding water, we need to first calculate the amount of water required. So again, because the text we are using is an American text, it's using the US customary units. So if I'm when using such formulas, you need to understand that it has some units in it, unit conversions in it. So this 8.33 pound per gallon, this is the unit conversion here in such a case. Okay. So if I'm looking at the SI version of it, simply I have a certain volume of water. I need to calculate this volume of water. So the dry unit weight that is desired will be multiplied by the difference in water content between the desired water content and the current water content of the bottle, multiplied by the volume of the compacted soil divided by the unit weight of water. So if you are using the same units for the unit weights, so gamma dry desired and gamma water, they have the same unit, they will cancel out. The W's are just ratios. So the volume of water will have the same units as the volume of the compacted soil. So simple, so easy. However, if you're using non-SI units, if you're using US custom units, you should use the upper formula, which is taking into account the amount of, the unit conversion. So again, this could be further translated into rate. So if I simply use sprinkler trucks, so here I know that this truck is covering a certain area. So I know my area. So I need to get what? The thickness. So the gallons per square yard. So this is, if you get exactly the same formula from the previous case, however you adjust it a little bit and you multiply by the lift thickness instead of the volume, and now you'll multiply by 9 square feet per square yard, you'll get this form. But what about the SI version? Simply get the previous number and divide it by the area. So this previous number, the number from the previous SI formula in the previous slide, you'll get it, and you divide by the area, you'll get what? The meter cube per meter square of area. Reducing moisture is a different story for sure. Reducing moisture is using one of two things. Either using the most ancient Egyptian invention, one of the most famous ancient Egyptian invention, which is rippers. Of course, ancient Egyptians used them using cows or horses, but now they are used in modern machinery, or disc harrows. So in here, the idea here is that you are exposing the soil, you are aerating the soil in order to make it lose humidity from it. So this will only happen if the soil has excess water in it, okay, which is a rare case if we are talking about construction works. It's more common in cases of agriculture. Mixing and blending it's not covered within our course. This is a grader. This is a top view of a grader, and this is a photo of a grader. This is not within our scope, of course, within this course. However, it is very simple. You will just get the productivity from a grader from just from the catalog. It's nothing. There is nothing complicated about calculating things with the grader. That's it for today. And again, if you have any questions, please insert them as comments on this video.